Good morning. This is the recording for the week of April 8th, since I will be out for STAR testing and EOC testing on Tuesday and Wednesday morning. Remember, this is being recorded for learning purposes. Okay, so assignments that were due last week, we finished up Unit 4, took your test on Thursday, and then started Unit 5 on Friday, which is trig. If you haven't done your Unit 4 test, please do so as soon as possible. I know some of you guys are struggling on the Part 2. So I'm going to help you a little bit there today. If you haven't done your USA test prep, again, those are easy 5 points. Please get those turned in as soon as possible as well. Okay, so let's start with writing equations of circles. So given the equation, it's always good to have, x minus h quantity squared plus y minus k quantity squared. And I still have yet to fix this from last week. hk is your center, and y and r is your radius. So given a picture, it's really easy. I have the center, obviously. I can find that real quickly. Positive 2, negative 1. To find the radius, you simply count. 1, 2, 3, 4. And so I just plug this into the equation. X minus 2 squared plus y minus negative 1 squared equals 4 squared. So again, just to simplify the signs, x minus 2 quantity squared plus, again, having the two negatives here together, I can make that into one giant positive sign. Hopefully remember from previous math classes. So y plus 1 quantity squared, and then 4 squared is 16. So that would be my equation. All right, so if I have the equation and the diameter, or the equation and the radius, again, it's just plugging in information. So if my diameter is 10, my radius is half of that, so 5. So x minus negative 2 squared plus y minus 8 squared equals 5 squared, and I kind of ran out of room. So again, simplifying the signs, x plus 2 squared plus y minus 8 squared equals 25. And you're done. Identifying the center and the radius. So my center would be at the point 1, negative 4. And if you need to, you can change this to y minus negative 4. So it looks more like the equation where I have minus and minus. Square root of 9, 3. So again, not too hard. Those did show up a little bit on your Unit 4 test. All right, so provide the equation. Given the center, always good to have. So this is h and k, and a point on the circle. So in other words, I have to find my radius, because I need that for my equation. So x minus h squared, y minus k squared equals r squared. So I'm missing r, not a big deal. By definition, the radius is the distance from the center of the circle to a point on the circle. So if I find the distance between these 2 points, I will have my radius. So x2 minus x1 squared plus y2 minus y1 squared. And again, it doesn't matter which one is x1 or 0.1, 0.2, it all works out in the end. So my radius is equal to, okay, so I'm just going to say my center is being 0.2, so negative 13 minus negative 10 squared plus negative 16 minus negative 16 squared. So again, dealing with the double negatives, that's really a giant plus sign, and so is this guy there. Not a big deal. So negative 13 plus 10, negative 3 squared, plus negative 16 plus 16 is nothing, so 0 squared. So my radius is the square root of 9, so my radius is 3. So now that I have h, k, and r, I can plug them into the equation and be done with it. So x minus negative 13 squared plus y minus negative 16 squared equals 3 squared. Again, simplify my signs, x plus 13 squared, y plus 16 squared equals 9. All right, so sketching a graph, again, pretty simple. I have my center, HK. So again, this is negative, or x minus negative 3. So my center then would be negative 3, oops, positive 3. See, I did it on the wrong one. Yuck. So there's my h. My k would be y minus negative 1. So k is negative 1. Again, my radius is the square root of 9. So 3. So plot your center. Positive 3, negative 1. Isn't it pretty? From there, it's counting. So since my radius is 3, I'm going to go 3 right, 3 up, 3 left, 3 down. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. That looked a little high. Okay, so once I have those points, connect them. And again, I don't expect you to have a perfect circle sketching by hand. Mine's not perfect by any stretch of the imagination, but close enough. Okay, just count once you have your radius and you're done. All right, so finding the intercept. So this is something we didn't talk about last week, partly because it wasn't on your test. So for a circle, you can have anywhere between 0 intercepts as in it doesn't cross either the x or the y-axis, all the way to 4, which means it crosses both the x and y-axis twice. I can have 1, I can have 2, I can have 3, anywhere between 0 and 4. Okay, so if I'm looking for my x-intercepts, remember from pre-algebra, algebra 1, that y is equal to 0. So basically, this goes away. Actually, no, just kidding. Doesn't algebra a lot of the times, though. So I'm going to plug in 0 for y. So x plus 1 squared plus 0 minus 1 squared equals 10. Solve for x. So this is negative 1 squared, which is 1. This I would have to FOIL. Again, going back to pre-algebra algebra. X squared plus 2x plus 1 plus 1 equals 10. So combining like terms, x squared plus 2x plus 2 equals 10. Again, going back to algebra and quadratics, I'm going to move the 10 to the other side so that I have it equal to 0. Okay, so I'm looking for factors of 8, negative 8, that add to 2. So factors of negative 8, I could have negative 1, positive 8, positive 1, negative 8, negative 2, positive 4, positive 2, negative 4. I want them to add to 2, so that's these guys here. So this now factors down into x minus 2, x plus 4 equals 0. Using your zero product property, x equals 2, x equals negative 4. And again, here it doesn't matter. Those are our two intercepts, 2 and negative 4. If I wanted to write them as points, I could say 2, 0, negative 4, 0. And so now I have to do pretty much the same thing for my y-intercepts. So if I'm looking for my y-intercepts, I know x is equal to 0. So 0 plus 1 squared, y minus 1 squared equals 10 again. So 1 squared plus, again, FOILing this out, y squared minus 2y minus 1 equals 10. I didn't really need to put the parentheses because I'm adding. So I'm just going to go ahead and delete those. All right, so combine like terms. A 1 squared is 1, and 1 minus 1 is 0. So this guy cancels out with that guy. So y squared minus 2y. Again, I'm going to move the 10 to the opposite side by subtraction. So minus 10 equals 0. So this time I'm looking for factors of negative 10 that subtract to give me a negative 2. So negative 10 and 1, 10 and negative 1, 5 and negative 2, negative 5, positive 2. That's all my factors of negative 10. I feel like I did something wrong here. Ah, yes, I did. A negative y times a negative y is a positive 1. A negative times a negative is a positive. Must remember that. Okay, so that's a plus. So those don't actually cancel each other out after all. So 1 plus 1 is 2. And 2 minus 10. So this would be y squared minus 2y plus 2 equals 10. Okay, so this would be a minus 8. Yeah, we'll just go ahead and erase that. So minus 8. Okay, so we're using basically the same factors, which is nice. This time I have to have them equal to -2 when I add them, or -2. So I want to use these two. So y plus 2, y minus 4 equals 0. Again, if you're ever unsure, you can check by using the FOIL method. Again, using my zero product property, I can set these both equal to 0 and solve for y. So y equals -2, y equals positive 4. So as ordered pairs, 0, -2, 0, positive 4. So this circle has 4 intercepts. It crosses both axes twice. So here there's not a whole lot of geometry. It's really just all algebra. So I've got to use those algebra skills. Okay, 414 has you finding the equation through 3 points. Yeah, not the easiest thing to do. I would suggest using some type of graphing program to do this if you had a choice. So I have points A, B, C, where A is -1, 1, B is 5, 1, and C is 4, -4. So you got the circle, which is great. You can visually see it. Okay. Start with creating a triangle ABC. Okay, and then we're going to find the midpoint of each side of the triangle. And again, I used GeoGebra to do this. Made it a little bit faster, a little bit easier. So I labeled those D, E, and F. So once you have your midpoints, you are going to draw in the perpendicular bisectors from each point. Okay, so there's the perpendicular bisector going through D. Here's the perpendicular bisector going through E. And the perpendicular bisector going through F. So again, using GeoGebra, it's a little bit easier because it will actually find it for you quicker. But you can do this by hand as well. But their point of intersection, G, happens to be the center of my circle. So if memory serves, we found the end center of our triangle, which is also the center of the circle. Maybe the wrong definition, vocabulary word. Okay. Again, to find my radius is just the distance from my center, which I just found, to a point on the circle, and I have 3 points to choose from. So it looks like I chose my center and point A. So I found this distance, that radius. Could I have gone and used B and G? Absolutely. Could I have gone and used G and C? Yes. Does not matter. So when I did my distance formula, I came up with a radius of the square root of 13. Not a very nice radius, but yeah. Again, plugging it back into the equation is always your last step. So the square root of 13 squared, hopefully you guys remember this from geometry or algebra 1, is just 13. The square root and the square kind of cancel each other out. So again, plug it into the equation. Use GeoGebra or Geometry Sketchpad or something to help with this. I think it will be easier than doing it by hand. But again, you can use the midpoint formula and sketching the perpendicular bisectors, you can graph it all. It's just, I think it's easier if you just use GeoGebra. All right, so a circle has an equation. Translate the circle 2 units to the left and 4 units down, write the equation of the new circle. So the only piece of information I really need to know is that my center of my given circle is at -2, 1. Because I am translating, I am sliding, I'm going to have an isometric image, which means, again, same shape, same size. So if I'm going 2 units left, that would be subtract 2, so x minus 2. If I'm going 4 units down, that's y minus 4. So again, using my center here, so my new center is going to be at -2, and I said subtract 2 to go left. 1, I'm going down 4, so minus 4. So my new center is at -4, -3. So there's H and K. Again, since it's an isometric image, my radius is going to stay the same. So R still equals the square root of 8. So my new equation then becomes y minus -4, so plus 4, squared, plus y minus -3, so plus 3, squared, equals 8. So again, not too difficult, not too bad. Okay, so that's kind of the end of Unit 4. Review the theorems and everything else for the part 2. All right, so 5.01 was Friday's assignment. So this was dealing with tangents. As I said, this unit is dealing with trig ratios. So tangent is equal to the opposite over the adjacent. So if I'm looking at angle A here, the opposite is 32. The adjacent leg, so this guy is always the hypotenuse. That guy doesn't change. The adjacent leg would be this 24 here. And again, we're mathematicians, so we like to simplify things. So 32 and 24 are both divisible by 8. So 4 over 3. All right, so if I'm looking at angle C, the opposite of him is now the 24. And his adjacent leg is the 32. Adjacent really just kind of means next to. So we have 3/4. B doesn't really have a tangent because the opposite of angle B is the hypotenuse, not a leg. Okay? So those are easy to do, just opposite over adjacent, opposite over adjacent, opposite over adjacent. All right, so this says find the missing side length, round to the nearest tenth. Okay, so again, we're dealing with tangent. I have my angle measurement this time, 73. Has to be equal to the opposite. Oops. This is a bad picture because I actually don't have the opposite. We'll assume he's over here now. Okay, we'll make my opposite 6. That'll give us an answer at least. Over the adjacent, which is x, Okay, so using properties, I'm going to kind of multiply by x to undo the division. So x times the tangent of 73, oop, left out a 3, oop, 73 has to equal 6. So again, division undoes the multiplication, so x is equal to 6 divided by the tangent of 73. Now, what I suggest you do is put this in your calculator exactly as is. Okay, there is a trick to this, however. You first need to make sure that your calculator is in degrees. So what you do is on your TI 80, whatever, 84, 83 calculator, you're going to go to mode, which is next to the second button. Okay. Once you go to mode, it's about the third one down. You have a choice between radians and degree. You want to highlight degree and make sure it's kind of highlighted because these are degrees, 73 degrees. Okay, once you've done that, you can hit second mode and that'll take you back to your home screen. But make sure that you are in degrees. Otherwise, you're going to get some very bizarro answers. Okay, so when I type this into my calculator, 6 divided by, the tangent is above the closed parentheses, so 2 above 9. 73, close parentheses, and enter. So I get x to be, okay, so it said round to the nearest tenth. So 1.8. Again, I came out with 1.8343, blah, 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 blah. You can do this by doing the tangent of 73, which is 3.27 equal to 6 over x. So x equals 6 over 3.27. You come out with the same answer. Again, we're rounding, so either way kind of works, and it's up to you. I just say typing in as tan 73 is the whole entire part of the problem. Your choice. Okay, so inverse tangent means instead of looking for the side, we're looking for the angle. So tangent inverse in the calculator looks like this, tangent -1. And we get that by going second tan. So it's real easy to find on the calculator. Okay, so find the indicated measure. Okay, so the tangent of some angle, and angles we typically use the Greek theta to represent our unknown angle, like a 0 with a horizontal line through it, has to equal the opposite 9 over 21. Well, I could attempt to plug stuff in there, but I don't really want to. So what I can say is theta, my angle, is equal to the opposite, tan -1 of 9 over 21. If you wanted to, you could simplify 9 over 21, 3/7. That works as well. You can go ahead and do 9 divided by 21 and put that decimal in. I'll be honest with you, I'm not a big fan of doing it that way just because I feel like you're rounding the decimal and then you're rounding your answer. So you're going to be a little bit off versus just rounding once. I prefer to round once. Okay, so again, put this in the calculator. So second tan gets you the inverse of tangent. 9 divided by 21. Close parentheses. And we get theta to be about 23.1985. Decimal, right? If I put in 3/7, I get the exact same answer. So it's set to the nearest degree. So theta is equal to 23 degrees. Okay. You don't have to use the Greek letter theta if you just want to put a question mark there. If you want to label this just X, that's fine. However you want to go about it. All right, so assuming line YZ is tangent to the circle X, what is the measure of YXZ to the nearest whole degree? So YXZ. So this guy here. So I'm going to call this guy theta. Again, if I wanted to, I could just call him X. He's angle X line as well, right? So the tangent of theta has to equal the opposite, which in this case is 20, over the adjacent leg, which is 15. So the tangent of theta has to equal 4/3, again dividing by 5. So theta equals the inverse tangent, so tangent -1, 4/3. Again, I can put that into my calculator absolutely as it is. So tangent -1, 4/3, close parentheses inner, theta is equal to 53.13 degrees. Again, it's set to the nearest whole degree, so theta is equal to 53 degrees. Again, you could call him X, it doesn't really matter. Okay, if you have questions, email me. Again, this week you have a really easy week. Today you have 5.02, which again is dealing with tangents. This is kind of the rest of the week for you. Missing assignments. Turning these in will increase your grade the most. And we all want to pass geometry. We don't want to have to retake it. Corrections on part twos. Again, here you can get full credit. Might as well attempt it. Look at my feedback. Retest any part ones that you're not happy with. If you have your attempt, your second attempt, do it. If you have a second attempt on the quizzes or the mid-unit assessments, bring up those grades, or you can work ahead. Again, English 1 EOC is Tuesday, tomorrow, and English 2 EOC is Thursday. Again, you have 5 hours. Take your time. Make your English teachers proud. And you don't want to have to retake it in the summer, so take your time. All right. Contact me if you have any questions or concerns. I will reach out probably more in the afternoons, Monday, today, Tuesday and Wednesday, because I'm doing testing as well. And I'll see you guys next week.